Hello students and good morning. So now I am doing class for class 11 science. The topic is trigonometrical ratios of compound angles. So this is your continuation class. Since we were doing this topic, since we have done this topic in the last class also, so today is the continuation class. Okay, the topic is trigonometrical ratios of compound angles. So same exercise 4 mark section, page number 139. So let's do this question number 1, prove that, and this is from 4 marks section. So question number 1 is, you have to prove that sine square alpha plus sine square 120 minus alpha, 120 degree minus alpha plus sine square 120 degree plus alpha is equal to 3 by 2. You have to prove LHS is equal to RHS. Okay. So now let us prove it. So here let us write left hand side is equal to sine square alpha plus sine square 120 minus alpha plus sine square 120 degree plus alpha. Okay. And you have to prove this left hand side is equal to 3 by 2. So how will you prove it? Now there is first term sine square alpha, it is kept as it is, and this second and the third term should be simplified because it is in the form sine of a minus b and this is sine of a plus b, but there is also a square. You can write it within whole square. This second term and the third term can be written within whole square. Okay. So which is equal to, this is your sine square alpha plus, now this is sine of 120 degree minus alpha, second bracket close, whole square. So you can write down like this. Similarly, plus within second bracket, here also you can write sine 120 degree plus alpha, second bracket close, whole square. Is that clear? So now within whole square, for both these term, you can use the formula of sine of a minus b and this is sine of a plus b. So you should know this compound angle formula, right? So which is equal to, this is your sine square alpha plus, now within bracket this is sine a. What is sine a? Sine 120 cos alpha sine a cos b minus cos a cos 120 sine b, that is your sine alpha, this is whole square. Similarly, plus within bracket this is your sine of a plus b. What is the formula for sine of a plus b? Sine a cos b plus cos a sine b. So this is sine 120 sine a cos b plus cos a sine b. This is your whole square. So I think I've understood it. So now you can get the value for, you can find out the value for sine 120 and cos 120. So let us get the value for sine 120, right? So how can you get the value for sine 120? This 120 degree can be written as 180 minus 60 or 90 plus 30. So let us write it as sine 180 degree minus 60 degree. So what is this formula? What is sine 180 minus theta? So this lies in the second quadrant. In the second quadrant, sine is always positive and 180 is even multiple of 90. So sine remains as it is. That is sine 60 degree, which is equal to, what is the value? It is root 3 by 2. That is a standard value, right? Similarly, cos 120. So it is cos 120, which is equal to cos 120 can be written as again 180 minus 60 degree, right? So you know that 180 minus 60 lies in the second quadrant. In the second quadrant, cos is always negative. Since 180 is 90 into 2, even multiple of 90, so cos remains same. So that is minus cos 60 degree, which is equal to minus half. So we have got the value for cos 120 degree minus half and sine 120 as root 3 by 2. So let us put the value here. So which is equal to sine square alpha plus What is sine 120? It is root 3 by 2 cos alpha. What is cos 120? It is minus half, so minus into minus plus half. This is your sine alpha whole square plus, within bracket, what is sine 120? This is root 3 by 2 cos alpha. And what's about cos 120? This is minus half sine alpha whole square. Is that clear? So I think I've understood it. Okay. So now let us simplify it. Which is equal to, this is your sine square alpha plus, what is the formula that you can use here? This is a plus b whole square. You know a plus b whole square. A square plus 2ab plus b whole square. What is a whole square here? A whole square is root 3 by 2 cos alpha whole square, that is 3 by 4 cos square alpha plus twice ab. What is twice ab? 2 into what is a? Root 3 by 2 cos alpha into what is b? Half sine alpha. Plus, what is b whole square? That is half sine alpha whole square. That is your 1/4 sine square alpha. Is that understood? Next, this is again, this is a minus b whole square. So you know a minus b whole square plus, what is a whole square? Root 3 by 2 cos alpha whole square. That is 3 by 4 cos square alpha minus twice ab. What is twice ab? 2 into what is a here? It is root 3 by 2 cos alpha into what is b? Half sine alpha. It is half sine alpha. Then plus b whole square. That is half sine alpha whole square. That is 1/4. This is sine square alpha. Is that understood now? So you can cancel here 2 into plus 2 into root 3 by 2 cos alpha into half sine alpha. This will be cancelled, right? So now let us simplify it. This is sine square alpha plus 3 by 4 cos square alpha plus 1/4 sine square alpha plus 3 by 4 cos square alpha plus 1/4 sine square alpha. Okay. Now let us simplify it. This sine square alpha is kept as it is plus, now this second and fourth, 3 by 4 cos square alpha plus 3 by 4 cos square alpha can be simplified. 3 plus 3 is 6, because this is 4. 3 plus 3 is 6 by 4 cos square alpha. This is 6 by 4 cos square alpha plus 1/4 sine square alpha plus 1/4 sine square alpha can be simplified. 1 plus 1 is 2 by 4 sine square alpha. Is that clear? So let's simplify it further now again. So let us write it here. So which is equal to, this is sine square alpha plus, so here you can cancel it, 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 2s are 4. So this is sine square alpha plus 3 by 2 cos square alpha, 3 by 2 cos square alpha plus, it is half sine square alpha. It is half sine square alpha. Now let us simplify it. So again you can add first and third term. Sine square alpha plus half sine square alpha. 2 into sine square alpha is 2 sine square alpha plus sine square alpha. That is 3 by 2 sine square alpha. This is 3 by 2 sine square alpha plus 3 by 2 cos square alpha, right? Next, you can take common here. What is common in this case? 3 by 2 sine square alpha plus cos square alpha, which is equal to, what is sine square alpha plus cos alpha? That is 1. So it is 3 by 2 into 1 is equal to, what is the answer? It is 3 by 2. So it is proved. So we have proved this LHS is equal to RHS. Okay. So you can copy it Now we'll do the next question. So now we'll do the next question, that is question number 2. So this one number 3 is your homework. This one number 3 is same as problem number 1. We have just done it. Okay. So this number 3 is your homework. So let's do this question number 2 here. So let us prove that sine square pi by 8 plus theta by 2 minus sine square pi by 8 minus theta by 2 is equal to 1 by root 2 sine theta. That means you have to prove LHS is equal to RHS. So let us write down left hand side now. So here LHS is equal to sine square pi by 8 plus theta by 2 minus sine square pi by 8 minus theta by 2. So how can you prove this LHS is equal to RHS? So which formula is used in this case? So we can take this pi by 8 plus theta by 2 as A and this pi by 8 minus theta by 2 as B. So this is your sine square A minus sine square B. So what is the formula that you can use here? What is sine square A minus sine square B? What is the formula? It is sine of A plus B into sine of A minus B. You can use this formula in this case. So which is equal to sine of, what is A out here? It is pi by 8 plus theta by 2 is A plus B. What is B? Pi by 8 minus theta by 2 is B. That is your sine of A plus B. Next, sine of A minus B. Sine of, what is A? Pi by 8 plus theta by 2 minus B. What is minus B? Minus pi by 8 minus or minus plus. This is theta by 2. Right? So next. So here you can cancel this theta by 2. Theta by 2 gets cancels. Your pi by 8 will be cancelled. So which is equal to sine, what is pi by 8 plus pi by 8? It is 2 pi by 8 into sine, what is theta by 2 plus theta by 2? It is 2 theta by 2. So here you can cancel 2 ones are 2, 2 4s are 8. Here 2 gets cancels. So which is equal to, this is your sine pi by 4 and this is your sine theta. Right? So this is sine pi by 4 means sine 45. What is the value for sine 45? It is 1 by root 2. It is 1 by root 2 into sine theta. So it is proved. So I think you have understood it. So we are using that formula sine square A minus sine square B is equal to sine of A plus B into sine of A minus B in this problem. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is one number 4. So let us prove this. Tan 70 degree is equal to 2 tan 50 degree plus tan 20 degree. Let us prove LHS is equal to RHS. So in this case you cannot prove it from left hand side or from the right hand side. So we have to use different method in this case. So we know that is tan 70 degree is equal to, this is tan 50 degree plus 20 degree, right? This 70 degree can be written as 50 degree plus 20 degree. Now keep the left hand side as it is. So simplify this right hand side. You can use the formula of tan of A plus B on the right hand side, isn't it? So tan 70 degree is kept as it is on the left hand side. So let us use the formula of tan of A plus B. So what is the formula? Tan A. What is tan A? Tan 50 plus tan B is tan 20 degree divided by 1 minus tan A tan B, that is tan 50 degree tan 20 degree. So below tan 70 degree there is 1. So what will you do now? You can do cross multiplication. Now you can do cross multiplication. So now let us cross multiply tan 70 to 1, tan 70 degree minus tan 70 degree, tan 50 degree, tan 20 degree, which is equal to, now cross multiply by 1 here, it will be 1 into tan 50 degree, tan 50 degree plus tan 20 degree. Okay. Now in this case, on the left hand side, you have to simplify this second term. That is tan 70 and tan 20 can be simplified because 70 plus 20 is 90 degree. These are complementary angles. You know that if the sum of the two angles is 90 degree, then these two angles are known as complementary angles. So either you can change this 70 to 20 or 20 into 70. You have to simplify only one angle, right? So, or this is tan 70 degree minus tan of, it can be written as 90 minus 20. Let us change this 70 into 90 minus 20. Let us keep them as it is, that is tan 50 degree and 20 degree remains as it is, which is equal to, this is your tan 50 degree, right hand side is also kept as it is. Okay, tan 50 degree plus tan 20 degree. Or now this is tan 70 degree minus, what is this, tan 90 minus theta, cot theta, you know that. This is cot 20 degree into, this is your tan 50 degree into, this tan 20 degree can be written as 1 upon cot 20 degree, which is equal to, this is your tan 50 degree plus tan 20 degree. Is that clear? So you can cancel this cot 20 degree. Or now this is tan 70 degree minus tan 50 degree is equal to tan 50 degree plus this is your tan 20 degree. So I think you have understood it. So now you can take this minus tan 50 degree to the right hand side, so that it becomes tan 70 degree is equal to tan 50 degree plus tan 50 degree plus tan 20 degree. Is that clear? So next you can add those similar terms, tan 50 plus tan 50, or now this is tan 70 degree is equal to tan 50 plus tan 50 is 2 tan 50 degree plus tan 20 degree. That means we have proved the required result, that is tan 70 degree is equal to 2 tan 50 degree plus tan 20 degree. So it is proved. So we have proved it. Okay, so we can copy it. We'll do the next question. So now we'll do the next question, that is question number 2. So here number 2 is simplify. That means you have to get the simplified value of the given expression. Okay, so let's do this number 2 of question number 2. So number 1 is your homework. You have to simplify number 1. I'll give you the hint for number 1. It is given cos A sin of B minus C plus cos B sin of C minus A plus cos C sin of A minus B. So you can use the formula of sin of B minus C, sin of C minus A and sin of A minus B. You know that sin of A minus B formula, isn't it? So you can use the formula and multiply by cos A here, multiply by cos B here and multiply by cos C there. So all the terms will be cancelled, I think, and you will get 0, I think. Okay, so answer for this first part is 0. Okay, so let's do this question number 2. So let us simplify this question. 1 plus sine of a minus b divided by cos a cos b plus sine of b minus c divided by cos b cos c plus sine of c minus a divided by cos c cos a. So let us simplify it. So which is equal to, let us write 1 as it is, plus what is sine of a minus b? Formula sine a, let us use the formula cos b minus cos a sine b divided by, it is cos a cos b. Is that clear? Similarly, what is sine of b minus c? Sine b cos c minus cos b sine c divided by, it is cos b cos c divided by cos b cos c, right? So next, plus what is sine of c minus a? Sine c cos a minus cos c sine a whole divided by, in the denominator we have cos c into cos a. Is that clear? So next, you can separate each and every term. You can separate this second term, you can separate this third term, you can separate this fourth term, and you can simplify it. 1 plus, let us separate this term, sine a cos b divided by cos a cos b minus cos a sine b divided by cos a cos b plus, similarly you can separate the third term here, sine b cos c divided by cos b cos c minus, next cos b sine c divided by cos b cos c plus, next sine c cos a divided by cos c cos a minus, what is the last term there? Cos c sine a divided by cos c cos a. Okay, so we have separated the term. Now we can cancel this, here cos b, here cos a, here cos c, here cos b, here cos a, and there you can cancel cos c, is equal to 1 plus, what is sine a by cos a? You know that this is tan a, minus what is sine b by cos b? You know that this is tan b, plus what is sine b by cos b? This is also tan b, minus what is sine c by cos c? Tan c, plus sine c by cos c? Tan c, minus what is sine a by cos a? That is your tan a. Okay, so here you can cancel this, tan a minus tan a can be cancelled, minus tan b plus tan b minus tan c plus tan c, which is equal to 1. So this is the simplified answer for this number 2 question. The answer is only 1. So I think I have understood it, so you can copy it, so you can do this number 1 at home. So let's do the next question now. So now we'll do the next question, that is question number 3 of number 2. So let us simplify this expression. It is given that tan of pi by 4 plus theta dot tan of within bracket 3 pi by 4 plus theta. So let us simplify it. So in this case we can use the formula of tan of a plus b. So what is tan of a plus b? Tan a tan pi by 4 plus tan b tan theta divided by 1 minus tan a tan b. that is 1 minus tan pi by 4 tan theta. So let us keep it within bracket, dot. Again within bracket. Now again you can use the same formula, tan of a plus b. Tan a, what is tan a? It is tan 3 pi by 4 plus theta plus tan theta, tan a plus tan b divided by 1 minus tan a tan b. 1 minus tan 3 pi by 4 into tan theta. Understood? So next, so this tan pi by 4 and tan 3 pi by 4, both this angle pi by 4 and 3 pi by 4 are standard angles. So you know that what is pi by 4? It is tan 45 degree plus tan theta divided by 1 minus, this is your tan 45 degree tan theta. Okay, pi by 4 means 45 degree. Similarly here also tan, what is pi by 4? It is 45 into 3. What is 45 into 3? It is 135 degree plus tan theta divided by 1 minus tan 135 degree into tan theta. So I think you have understood it. So you can put this value, tan 45 is 1. So it is 1 plus tan theta divided by 1 minus tan 45 is 1. 1 into tan theta is tan theta. Okay, into. Now within bracket, what is tan 135 degree? So let us get the value for tan 135 degree. Okay, so is equal to tan, what is 135? It is 180 degree minus 45 degree, which is equal to, what is tan 180 minus theta? This lies in the second quadrant. In the second quadrant, tan is always negative. Minus 180 is even multiple of 90, 90 into 2. So if it is even multiple of 90, tan remains same, that is minus tan 45 degree. Minus tan 45 degree, which is equal to minus 1. So here tan 135 degree is minus 1 plus tan theta divided by 1. Since tan 135 degree is minus 1, minus 1 minus plus, so this is your tan theta. Okay, so here you can cancel this 1 plus tan theta, 1 1. So which is equal to, here minus is common within bracket, 1 minus tan theta divided by, here minus is taken common. So within bracket we have 1 minus tan theta divided by, this is 1 minus tan theta. So you can cancel them, which is equal to, what is the answer? So the answer is minus 1. So this is the simplified value of this expression, that is minus 1. Okay, now we'll do the next problem. You can copy it. So now let us simplify this number 4. It is given that sine of b plus c into sine of b minus c plus sine of c plus a into sine of c minus a plus sine of a plus b into sine of a minus b. So in this case we can use this formula, that is sine of a plus b into sine of a minus b, which is equal to, this is sine square a minus sine square b. So let us use this formula now. Okay, so here sine of b plus c into sine of b minus c, use that formula, which is equal to sine square b minus sine square c plus, similarly what is sine of c plus a into sine of c minus a? This is sine square c minus sine square a plus, what is sine of a plus b into sine of a minus b? This is sine square a minus sine square b. Is that clear? So you can cancel all the terms here, sine square b minus sine square b minus sin square c plus sin square c plus minus sin square a plus sin square a, which is equal to, what is the answer? The answer is 0. So I think you have understood it. So you can copy it. Now we'll do the next question. So now you have to find out the expansion of, let's do this question number 2 here. This number 1 is your homework. So number 1, I'll give you the hint. So how can you expand sine of a minus b plus c? You can take this a minus b as a and c as b. So use the formula sine of a plus b. Or you may take a as a minus within bracket b minus c. So here you can take a as a and b minus c as b, so that you can use the formula of sine of a minus b. Either you can use here sine of a plus b, a minus b, you take it as a and c as b. So this is your sine of a plus b. You can use this formula. Or you may use the formula of sine of a minus b. Here a is taken as a, minus is taken common, b minus c, and then that b minus c should be taken as b, so that you can use the formula of sine of a minus b. So in this way you can do this expansion. So let's do this question number 2 here. It is given that tan of a plus b minus c. So let us take this a plus b as a and c as b. You have to find out the expansion of tan of a plus b minus c. So let us take this a plus b as a and c as b. So this is your tan of a minus b, isn't it? What is the formula? What is tan of a minus b? Your tan a is tan of a plus b minus tan b is minus tan c, whole divided by 1. Since there is minus, 1 plus tan a. What is tan a? It is tan a means a plus b, and what is tan b? It is tan c. So we have used the formula of tan of a minus b, that is tan a minus tan b upon 1 plus tan a tan b. Okay. So again you can use the formula of tan of a plus b here. So what is tan of a plus b here? It is tan a plus tan b divided by 1 minus tan a tan b. Okay, then you have to write minus tan c. Similarly in the denominator, 1 plus, what is the formula for tan of a plus b? You know that. What is tan of a plus b? It is tan a plus tan b divided by 1 minus tan a tan b. Bracket close, then you can write tan c. Okay. Now let us get the LCM both in the numerator as well as in the denominator. Let us take the LCM now. So in the numerator, what's the LCM? What's the LCM in the numerator? It is 1 minus tan a tan b. 1 minus tan a tan b is the LCM. Okay. So in the numerator we have tan a plus tan b. In the numerator we have tan a plus tan b, and this minus tan c should be multiplied by this LCM 1 minus tan a tan b. So what is it? 1 into minus tan c, then next minus tan c is multiplied by minus tan a tan b. So minus into minus plus tan a tan b tan c plus tan a tan b tan c. Is that clear? So now in the denominator, what's the LCM again? In the denominator also 1 minus tan a tan b is the LCM. 1 minus tan a tan b is the LCM. Okay. Now this 1 minus tan a tan b is multiplied by 1. What do we get? 1 minus tan a tan b. Is that clear? Next, this plus tan a into tan c plus tan a tan c plus tan a tan c. Now again, this plus into plus is plus tan b tan c. This tan C is multiplied by both tan A plus tan B. That is, first it is plus tan A tan C plus tan B tan C, plus it is tan B tan C. So I think you have understood it. So this LCM can be cancelled here from both the numerator as well as in the denominator. So now the terms are, what are the terms? Tan A plus tan B minus tan C plus then tan A tan B tan C, tan A tan B tan C. This whole divided by 1 minus tan A tan B plus tan A tan C plus tan B tan C. So this is the required expansion. So this is the expansion. This is the answer. Okay. So I think I've understood it. So you can copy this problem. So this number 1 is your homework. Okay. So now let's do the next question now. So now we'll do the next question, that is question number 4. If sin alpha sin beta minus cos alpha cos beta plus 1 is equal to 0, you have to prove that, you have to show that sin of alpha plus beta is equal to 0, and hence you have to deduce that. That means you have to prove that 1 plus cot alpha tan beta is equal to 0. So from given you have to prove sin of alpha plus beta is equal to 0. So let us write down the given part. Here given is sin alpha sin beta minus cos alpha cos beta plus 1 is equal to 0. Okay. And you know the formula of cos A cos B minus sin A sin B, isn't it? So let us take these two terms, that is sin alpha sin beta minus cos alpha cos beta, to the right hand side, and let us keep this one on the left hand side. 1 is equal to, this is your cos alpha cos beta, this becomes plus, minus this is your sin alpha sin beta. Is that clear? So what is the formula for cos A cos B minus sin A sin B? It is cos of A plus B. Or 1 is equal to, this is cos of alpha plus beta. Or you may write cos of alpha plus beta is equal to 1. So let us mark it as number 1. This is from given. Now can you prove sin of alpha plus beta is equal to 0? But you can write sin of alpha plus beta in terms of cos, isn't it? You know this formula, that is sin theta is equal to root over 1 minus cos square theta. You know this, isn't it? So similarly, what is the formula for sin of alpha plus beta in terms of cos? It is root over 1 minus cos square alpha plus beta. You know this formula, isn't it? So using this formula, you can prove that sin of alpha plus beta is equal to 0. So, or now this is sin of alpha plus beta is equal to root over, this is 1 minus, what is cos of alpha plus beta? 1 over square. Or sin of alpha plus beta is root over 1 minus 1 square is 1. Or this is sin of alpha plus beta is equal to 1 minus 1 is 0, root over 0 is 0. So it is proved. So we have done this first part. Okay. Now let us deduce that 1 plus cot alpha tan beta is equal to 0. That means you have to prove that this LHS is equal to 0. LHS is equal to RHS. So now let us write down here left hand side. So what is left hand side out here? It is 1 plus cot alpha tan beta. It is 1 plus cot alpha tan beta. Okay. So let us write this cot and tan in terms of sine and cos. So let us simplify it. 1 plus what is cot alpha? This is cos alpha by sine alpha into what is tan beta? It is sine beta divided by cos beta. Okay? So let's take the LCM. So what's the LCM out here? It is sine alpha cos beta is the LCM. You know that, how to get the LCM, isn't it? So sine alpha cos beta into 1 is sine alpha cos beta plus. Next, it is cos alpha sine beta, which is equal to, now this is in the form sine A cos B plus cos A sine B. What is the formula? It is sine of A plus B. You know this formula, isn't it? That is your sine of A plus B. This is just like your sine A cos B plus cos A sine B. Here A is alpha and B is beta. So what is sine of A plus B? Sine of alpha plus beta divided by, this is sine alpha cos beta, which is equal to, now what is sine of alpha plus beta? We have just proved it, which is equal to 0. 0 divided by denominator is kept as it is. This is sine alpha cos beta. So 0 divided by number is always 0. So it is done, proved. So I think you have understood it. So you can copy this problem. So I hope you have understood all the problems that we did today. So you revise all the problems that we did so far in trigonometrical ratios of compound angles. So this much is for today. So in the next online class, we'll do more problems on this chapter, that is trigonometrical ratios of compound angles. So you can copy it.